Hello everyone, I am Aswani, Assistant Professor, Department of CSE AIML at MLR Institute of Technology. Welcome back to another session of Artificial Intelligence. In today's session, we are going to learn about the certainty factor theory. In this session, we are going to see the certainty factor theory introduction, measure of belief and disbelief of certainty factor theory. We'll see the formulas for this measure of belief and measure of disbelief. And last, we will see the comparison between Bayesian reasoning and certainty factor theory. So, these Bayesian belief networks and certainty factor theory are Dempster-Shafer theory. These are used to find out the uncertainty in the events. So, we'll see what is the difference between Bayesian reasoning and certainty factor theory. Both are using to find out the uncertainty in the events. So, what are the differences? We'll see that comparison between these two also in this session. Let's see the introduction about the certainty factor theory. So here, analyzing a situation and drawing certain result about in the real world, we can't be sure about our conclusions. So by seeing the real world, we can't get come to a conclusion says that 100% it will happen. It is not happens in that scenario. We can't give that 100% conclusions. There is some uncertainty in that real world scenarios. Means I already said in the previous session, a human can't guarantee that a statement is 100% true without any evidence. If there is an evidence says that it is a guarantee that 100% will happen, then it will be true. If it is not such scenarios, then there is the uncertainty factor will be there in that statement. How much of what is the how we can quantify that uncertainty in that statement? That is the important one. If it is a human, then we can say okay, this much of factor. But for machines, it will be difficult by observing and analyzing. That is what a certainty factor theory. Certainty factor will be there. Says that so this much of belief is there, this much of disbelief is there in that statement. Let's see, there is some uncertainty in it for sure. We as human beings have the capability of deciding whether the statement is true or false according to how much certain we are about our observation. By observing something, we can get some conclusion. Okay, this much of certainty is there, this much of uncertainty is there. But machines do not have this analyzing power. So there is need to be some method to quantize this or uncertain in any decision made. To implement this method, the certain factor theory was introduced for systems which work on artificial intelligence. Certainty factor theory is popular alternative to Bayesian reasoning. So in the Bayesian belief networks, this Bayesian reasoning is used in a probabilistic distribution, whereas we are having statistical values, then we will go with the Bayesian belief networks. Means the data is important. Where the data is not there properly, then we'll go with the certainty factor. This is the major difference between this certainty factor theory and Bayesian belief networks. So the certainty factor definition, let's see. The certainty factor is a numeric value which tells us about how likely an event or a statement is supposed to be true. Means 98% is true, 70% is true, in such a way. The certainty factor is a numerical value which tells us about how likely an event or statement is supposed to be true. It is somewhat similar to what defined in a probability, but the difference in it is that an agent, after finding the probability of any event to occur, cannot decide what to do. After knowing okay 98% probability is there, but agent can't get any solution what to do next. So based on the probability and other knowledge that the agent has, this certainty factor is decided through which the agent can decide whether to declare the statement true or false. Okay, the value of the certainty factor lies between -1.0 to +1.0, where the -1.0 value suggests that the statement can never be true in any situation, and the +1.0 value defines that the statement can never be false. -1.0 it is uncertainty, plus 1.0 certainty. The value of the certainty factor after analyzing any situation will either be a positive or negative value lying this range minus 1.0 to plus 1.0. The value 0 suggests that there is no information about the event or situation. Minimum certainty factor is decided for every case through which the agent decides whether the statement is true or false. The minimum certainty factor is also known as the threshold value. For example, if the minimum certainty factor is 0.4, then if the value of the certainty factor is less than this value, then the agent claims that a particular statement is false. There is a threshold value. If it is the value of certainty factor value is less than this value, for example 0.2 is the certainty factor, then the statement is false. If it is above, then that statement is true. Okay, let's see some of uncertain terms and their interpretations. Definitely not, almost certainly not, probably not, maybe not, unknown, maybe, probably, almost certainly, definitely. These are the some uncertain terms which are used in the certainty factor theory. So let's see where we will use this certainty factor theory. In expert systems, which certainty factors, the knowledge base consists of a set of rules that have the following syntax. If then rules, already we have seen several times. If then rules are production rules. If then CF, where CF represents belief in hypothesis H given that evidence E has occurred. Let's see the significance of certainty factor in designing rule-based system. A simple approach and popular alternative to Bayesian network are belief network. Certainty factor used in cases where the probability are not known, difficult or expensive to obtain, where the statistical data or probabilities are not known completely. Then we'll go with the certainty factor. Better explanation of the control flow through a rule-based expert system. The certainty factor theory is based on two functions. One is measure of belief and another one is measure of disbelief. The measure of belief, the measure of increased belief in H is the hypothesis due to E is the evidence. The measure of disbelief, MD of H, E, the measure of increased disbelief in hypothesis H due to evidence E. Let's see the formulas. Measure of belief H, E equal to 1 when probability of H equal to 1. The probability of H is nothing but a prior probability of hypothesis H. Otherwise, max of probability of H given E, probability of H minus probability of H divided by 1 minus probability of H. That is measure of belief. The measure of disbelief is equal to 1 when probability of H equal to 0. The prior probability is 0, then we can say measure of disbelief is 1. Otherwise, probability of H minus minimum of probability of H, E, probability of H divided by probability of H. So here probability of H is the prior probability of hypothesis H being true. Probability of H given is the probability of that hypothesis H is true given evidence E. So the value of a measure of belief and measure of disbelief range between 0 and 1. The strength of belief and disbelief in hypothesis H depends on the kind of evidence E observed. Some facts may increase the strength of belief and some increases the strength of the disbelief. The total strength of belief and disbelief in hypothesis certainty factor hypothesis H, evidence equal to measure of belief minus measure of disbelief, where it lies between minus 1 less than or equal to certainty factor less than or equal to 1. The certainty factor theory provides a practical alternative to Bayesian reasoning. The certainty theory is not a mathematical proof but does mimic the thinking process of human expert. Let's see the example. Mycin, an expert system which is used to diagnose the infections. Let's see. Mycin was the earliest designed expert system in Stanford University in 1970s. Mycin is a well-known rule-based deduction system. Its expertise lies in domain of bacterial infections. In the human body, there is a blood infection. Then it will be diagnosed and it will prescribe what to do. Its job was to diagnose and recommend treatment for certain blood infection. It attempts to solve its goal of recommending a therapy for a particular patient by first finding the cause of patient's illness. Mycin was written in Lisp programming language. Mycin is mainly goal-directed system using the backward chaining reasoning approach. Mycin helps the physician to describe disease-specific drugs. So Mycin is the first expert application, so which is used to diagnose the blood infection, and which is used to suggest the treatment, and which is also suggest the specific drugs. Let's see the comparison of Bayesian reasoning and certainty factor. So probability theory is the oldest and best established technique to deal with the inexact knowledge and random data. It works well in such areas forecasting and planning where statistical data is available and accurate probability statements can be made. However, in many areas of possible applications of expert system, reliable statistical information is not available. We can't assume the conditional independence of evidence. If it is not there, then we can't guarantee that the results are accurate. As a result, many researchers have found Bayesian method unsuitable for their work in expert systems. Like this dissatisfaction motivated the development of certainty factor theory. Although the certainty factors approach lacks the mathematical correctness of the probability theory, it outperforms subjective Bayesian reasoning in such areas diagnostics. Just now we have seen Mycin. Certainty factors are used in cases where the probabilities are not known, are too difficult, or expensive. Let's see. The evidential reasoning mechanism can manage incrementally acquired evidence, the conjunction and disjunction of hypotheses, as well as evidence with different degrees of belief. The certainty factors approach also provides better explanation of the control flow through a rule-based expert systems. The Bayesian method is likely to be the most appropriate if reliable statistical data exist. The knowledge engineer is able to lead and the expertise available for serious decision analytical conversations. In the absence of any specified conditions, the Bayesian approach might too arbitrary and even biased to produce meaningful results. The Bayesian belief propagation is of exponential complexity and thus is impractical for large knowledge bases. So, here when the Bayesian network will work, will have this appropriate values, then only it will be work fine and it will give the accurate results. If the data is not available, then it is not work and it won't give the values, it will produce the biased values. Okay, let's see the summary. So in this today's session, we have seen the certainty factor, theory, introduction, measure of belief and measure of disbelief of H, E formulas, and certainty factor formula, measure of belief minus measure of disbelief, and the range is 0, 1 and the range minus 1, 1. And we have seen the first application, Mycin, and why we use the Mycin. There is a conversation and it will suggest the therapies also. Next, we have seen the comparison between certainty factor theory and Bayesian belief networks or Bayesian reasoning. Thank you.